Hi everyone! Here I am again, Sherlina A. Agcopra from Davao City National High School. Welcome to my YouTube channel. Let's get started with finding specific terms in a sequence. So let's have finding specific terms or terms in a sequence. For instance, to find the first three terms of a sequence, a sub n is equal to 3n minus 2, we substitute n is equal to 1 or 2 and 3 to the given formula. If n is equal to 1, to the formula a sub n is equal to 3n minus 2, which is our given formula from here. Now, substitute the value of n, which is 1, in here. So, let's have a sub 1. This subscript here, 1, is the number of, or the first number of the sequence, or the first term of the sequence. So, it's substituted in the formula here in n. So, becomes a sub 1 equals 3 times 1 minus 2. And then, perform the indicated operations. So, our a sub 1 becomes 3 minus 1. And that is, a sub 1 is equal to 1. So, our first term is 1. Now, if n is 2 naman, is the second term of the sequence. Again, do the same process here like we did in the first one. So, a sub n, or rather a sub 2 now, becomes 3 times 2. We substituted the value of n here, which is 2, and then minus 2. So, we have 6 minus 2, or a sub 2 is 4. Therefore, our second term is 4. When n is 3, or in the third term, we denoted as a sub 3 for the third term of the sequence. Again, the value of 3 for n is substituted in the formula again. So, 3 times 3 minus 2. So, our a sub 3 is 9 minus 2, which is 7, which is the third term of the sequence. Therefore, the first three terms of the sequence with the formula a sub n is equal to 3n minus 2 are 1, 4, and 7. These are the first three terms. Now, if you are asked for the fourth and the fifth terms of the sequence 1, 4, 7, and then the fourth and the fifth, all you need to do is to take the value of n, which is 4, and then substitute it again and do the indicated operation. So, again, for n is equal to 5, or the fifth term, we just substitute the value of n, which is 5, to the formula to get the value of the term, fourth and fifth term. Okay? Now, next is finding the general or end term of a sequence. Okay, let's have example 1. We have a sequence of 9, 11, 13, 15, and 17. So, in here, as you see, the difference between 11 and 9, 13 and 11, 15 and 13, 17 and 15, you have positive 2. So, the difference between each term is 2. So, D is equal to 2. Well, the first term, a sub 1, is equal to 9 here. Here. And then since we are just looking for the formula of the m term, we only substitute the value of a sub 1 and b from the general formula of a sub 1 is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. So since our a sub 1 is 9, so I'll substitute it here, then plus our n minus 1 times 2. And then do the distributive. 2 times n, you have 2n. 2 times negative 1, you have negative 2. So our formula is a sub n is equal to 2n plus 7. Okay, so let's try. This is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. What if you want to get the sixth term, or a sub 6? So let's try to go back to the formula. So let's change this subscript n here to 6. So we have a sub 6 is equal to 2 times 6 is 2 times 6 is 12 plus 7 is 19. So our a sub 6 is 19. Okay? Next example. Negative 6, negative 11, negative 16, negative 21. As you see it, there is a difference of negative 5 between negative 11 and 6, negative 16 and 11, and so on. So the difference between each term is negative 5. So negative 5 and d is equal to negative 5, while the first term is a sub 1, which is equal to this one, negative 6. Substitute these values, we get a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Our d is changed to negative 5. Our our a sub 1 here, the first term is 6. So do the indicated operation, you got a sub n is equal to negative 5 times n minus 1. Okay, now if you want to get the fifth term, so you have a sub 1, a sub 2, a sub 3, a sub 4. So our a sub 5 is, so subscript n here changed to 5. And in here is changed to 5. So our a sub 5 is equal to negative 5 times 5 is negative 25. Minus 1 is negative 26. Right? Okay. So our next term is, or rather our sixth term, 1, 2, 3, 4. Fifth term is negative 26. As you see it, from negative 21 plus negative 5, it's negative 26. Okay? Check? Okay, recheck your work if you are not sure. Our final answer for a sub 5 is negative 26. Okay? Hope you understand. Okay, next, we will try to apply what we learned from the previous examples. So let us practice now. So find the next 3 terms of each sequence. So as you see, you have 6, 9, 12, 15. What is the difference now between 9 and 6? 12 from 9. And then 15 to 12. So it's 3. So we add it here. So 15 plus 3, you have 18. Plus 3, you have 21. Plus 3, you have what? 24. Okay, for number 2, you have negative 7, negative 5, negative 3, negative 1, 1, 3. What is the a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, and a sub 8, a sub 9? Our last 3 terms. What do you think? And then what is the difference between negative 5 and negative 7, negative 3 and negative 5, negative 1 and negative 3, 3 and negative 1? It's 2, right? So we add 2 here. So 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. Am I correct? Check your work. For number 3, it's 3, 6, 12, 24. If you can see it, it's not the difference, but multiply 3 by 2, you got 6. 6 times 2, you have 12. And then 12 times 2 is 24. What do you think is the next term? So 24 times 2 is 48. 48 times 2, it's 96. 96 times 2, it's 192. Okay, check your work. For number 4, it says here 21 to 34, 55 to 34 to 55 and 80. So they have difference. Okay? So if you can see it, that when you add 21 to and 34 rather, you got 55. If you add 35 and 55, you got 89. If you add 55 and 89, what do you think is the next term? Try to check. It's 144. If you add 144 to 89, you have 233. And then 233 plus 144, you have 377. Okay, can you see it? Okay, I hope you can follow our pattern. So let's be reminded, or let us remember how to get the next sequence or the next term of a sequence. So let's try to understand. The first term of a sequence is represented by a sub 1, the second term is a sub 2, and so on. To determine the common difference of a sequence denoted by D, subtract a term by its preceding term. Like for example, this is now the preceding term. So subtract a term by the preceding term, like 9 minus 6, so you have 3. 12 minus 9 is what? 3. Okay. Next is, in finding the nth term of the given sequence, simply evaluate the sequence by substituting each positive integers 1, 2, 3, 4, and so on and so forth, depending on the term position being asked. Now, if the value of A and B are given, it would be very easy to find any term in a sequence using the formula, the general formula, which is A sub n is equal to A sub 1 plus the quantity n minus 1 times b. All you need to do is to identify the A sub 1 and the difference, and then substitute to get the term you want to look for. Okay? So in determining the formula of finding the nth term of a sequence, simply substitute the given of the values of A and D to the formula. A sub n is equal to A sub 1 plus n minus 1 times D, and then simplify. Okay? Yes, that's all for today. I hope you like the topic. Bye everyone. Don't forget to like and subscribe my YouTube channel. Bye.